Okay, welcome back, guys. This is our second class, and now we're going to talk about the function notation and the elements we require to make the graph of one function. This class will have like two parts. This first part is like the theory we need to have clear and understand in order then to apply the practice, which is make the graph of the functions we will study. So objectives for this class. We will define what's the main and range, differentiate the dependent and independent variables in a function, illustrate the relation of domain and range with a value chart, and differentiate the functions by their function rule and graph. This last objective is more for our second class. So in this first class related with this topic, we will fit or reach the first three objectives. Okay, when we talk about domain and range, to graph functions, we need to have clear the idea of what is domain and what is a range of a function. You probably have clear some of these because you study something related with the definition of function. But here we must have clear next. And if you couldn't conclude next, is because you don't have clear at all the definition of function. So every function is a relation, but not any relation makes a function. This is a good example of the definition of a function because at the end a function is a type of relation, but specifically the relation that has for each element of the domain one element in the range. So all relations work with two sets, inputs and outputs. Here is number two sets, inputs and outputs. And what we call inputs is normally called like domain, and what we call outputs, it's normally called like range. This is what we're going to study right now, domain and range of a function or of a relation in general. So domain and range. When you create a correspondence or a relation, you will have the correspondent or the relation of sets. Of course, this relation we have in here, -1, 0, 2, 3, 4, makes a function, no matter if those are related with the same. But the problem is when, for example, if the 2 is related with two values, it breaks apart the idea of a function. But like we have it right now, is a function, and we must be um, concentrate on that definition of domain and that definition of range. So what is domain? Is practically this set, the set of all these numbers, and range, the set of all these numbers, okay? So those sets are different because they have to suffer something. The relation they have is a procedure that the numbers suffer in order to be converted into another. I mean, this -1 then converts into a 4. This 0 then converts into a 7. This 2 then converts into a 3. So this is very interesting because the functions follow these kind of behaviors. So here we have the function in it. A function in essence is an example of what we're gonna do later. Showing you this right now just to have a clear idea about what's the domain and range. If you see here, you have this set of numbers, which is -2, 0, 3, and 7. Something interesting about sets in mathematics. Set of numbers or sets of numbers doesn't accept repetition of values, okay? So that's why here you will not see numbers repeated here the same. For example, -2 in this function, the function is this one. Then we will see what does it means and what type of function is this one. But right now, -2 as the value in the domain will make -7. How can you get this? Okay, this expression we have in here right now is called function rule. And this function rule tells you what's gonna be the behavior of the element of the range, which are depending of the value you get in the X. And that open to us another need to understand what's dependent and independent in mathematics. So this relation right now, it's okay. Spoiler alert, that's gonna be later, but right now this is a linear function, And all you need to do is like replace the value of x by the values on the domain you have. So by that way you will get these results. You can check. And I'm just gonna show you with -2. For example, if you have -2 instead of x, you're gonna have then 2 times -2, which is -4, and -4 minus 3 gives you -7. So this is the way to create a function, or show the relation that's making a function right now. So there are like point of view of the domain and range, not differences, because they are too related. They cannot be separated into another. So the domain are the values that makes the function works. The x values are the set of inputs in the function, and they are considered the independent variable. In a function machine, something I'm gonna explain very quickly, they are considered like the raw material. Okay, what about the range? The range are the result with the value of the function with the values of the domain, are outputs of the function. They are considered the dependent variable. And in a machine, or consider this function like a machine, practically the range becomes to be the product, the final product. Okay, function as a machine. Here is the explanation. If you see here, you have a machine where you introduce a raw material, and then through a long procedure, or sometimes short, you finish in here. And here, what do you have? Final product, maybe something like this, or something else. So what I wanted you to understand with this, I wanted you to understand that every time you have a function, you will work with some values, and then you're gonna have some results. And those values you use, and these results you get will create the function. So here is like the main idea of the function machine. Your input is an x value. Through the procedure, then you get an f of x value, or value of the range, which normally is considered with y. This f of x normally is the same as y. We will see that later. So independent and dependent variable. Here is very interesting, the idea of the dependency and the independency in math, because it's not the same as the other contexts you have been studied, dependent and independent. So all functions works with x and y values. All is double L, sorry. X and y values. So a function as a set of order pairs x comma y, because at the end this becomes to be x comma y. I mean here, those values together, -2 and -7, will make a point x comma y. 0 comma -3 will make an x comma y. 3 comma 3, 7 comma 11, etc. So that way you're gonna have this. I mean, this order pairs conclusion or set. Practically is another set. It's a set of order pairs. So it's an interesting, the idea of order pair. I think you're totally clear, because that's what we studied in the first class. So every order pair has an x coordinate, which is the independent variable, and a y coordinate, which is the dependent variable. And as I told you in the first class, to respect this every time the x goes first and then the y. So what means independent and dependent in mathematics? Because probably that's your question. I told you that in a different context, you are totally clear about what it is. But in math, it's a little bit different. So what's dependent and independent? In mathematics, independent means that you can take any value as long as the function doesn't have restrictions. We will see that restrictions later, but in the functions we will study, I think we won't have troubles like this one. But later on, you're gonna see other topics like the rational functions, which are the ones that work with expressions, algebraic expressions like fractions, and they consider some values that cannot be taken. So if the function have restrictions, the domain will have restrictions, and the independent values, variable, sorry, will have this restriction too. Okay, right now independent means that you can take any value. So the domain is related with the independent. So here you can take any value you want. I took negative 2, 0, 3, and 7, but you can take a 100, 1000, 1.02, 0.5, positive 1000, negative 1000, negative 1001, negative 0.2, any value you want. And then through that procedure, the function machine, you will get a result. And what means dependent? Dependent is a variable that is conditioned by the value of x the function get. And remember, you choose the x value. Then the y value is not a selection. Is not something you choose. Is something that gives you or is the result of the procedure you do with the x value you choose. So a function is a relationship between two sets. The domain, inputs, the range, outputs. So here we're gonna have clear this, that the inputs that are in the domain, all those inputs are called independent variables. And the outputs that are the values in the range, all these ones are called dependent variables. So be careful with this, dependent and independent, because it's the first part and it's important at the moment to make the graph. So here's an example. Given next function, which return the triple of a number, that's the function, f of x equals 3x. Using some x values for the functions, you can get some y values. And this is what we're gonna do in this example. So the function 3x doesn't have any restriction for the domain. Then we will study how to conclude this. I conclude right now. But right now, we need to be clear that we have to choose freely any value of x we want, any real number, and then see what happened with the result. Of course, I think that if you're clear that the function is a function that returns the triple of a number, you will know that if you choose 7, then you're going to have 3 times 7, which is 21. So the function is very simple. So I'm going to choose these values, getting negative 3, negative 1, 2, 5, and 8.5 like x values. Let's see what outputs or y values you can produce or you get as results. Of course, I think you can get the triple of each of these numbers very quickly. And this is what we're gonna do right now. But you must be clear here. I didn't choose negative 3, negative 1, 2, 5, and 8.5 because of something. No, or because a condition that I have. No, I did it freely. I choose this one because I want. And you can choose any other two or any other. In this case, I choose 5 values. You can choose any other 5 values, no problem. So we will do this in a value chart, and this is important at the moment to make the graph of a function. You must do a value chart every time you don't have an idea about the behavior of a function. And this is what we will do in the next class, because in next class we will conclude about the shape of the functions. Of course, you're doing a homework, an investigation related with this too. You're gonna have a better idea for next class if you do this homework as well. Okay. Here we have the example of the value chart. Function is next one. The value chart is this one. And I circle those things, the input and output and independent, because those are related with domain and range. Okay? So here we go. Interesting. The values that I choose, the x values, negative 3, negative 1, 2, 5, and 8.5. They will suffer a procedure called function machine. I call it like that. Okay, but the way that I teach. And the function machine will do something with this negative 3 and will convert into something else. Will convert into negative 9. So that y value, or this value we get in here, is the output, is the independent, is a value in the range. Okay? And that's something you already have clear. That independent variable or the input values are part of the domain. And the dependent variables or the output values are elements of the range. So here, if you see, all you have to do when you choose x values is replace that value of x in your function and operate them. I mean, here, f of x equals 3 times x, or 3x. F of negative 3, it's equal to 3 times negative 3, and 3 times negative 3 gives you negative 9. F of negative 1 is, I mean, choosing x like negative 1, is f of negative 1. Negative 3. Then, choosing x like 2, you're going to have f of 2, which is replace the value of x, and then you're going to have 3 times 2. Then if you choose x like 5, of course, you can choose many values as you want. And all you have to do is replace the value of x you're getting for the value you choose, and then get a result. If you see, you can compare, you can check the results are here. Each of these values are the triple of these numbers. 8.5 times 3, it's 25.5. So we already get the triple of each number. And it's very easy. You can check those values. And if you see here, all the points or all the values we make, or the elements in this function, of course, there are not all the elements. There are some more, there are many more, there are infinite. But right now, the ones we did makes this set of order pairs. And these order pairs will help you to understand better how's gonna be the behavior of that function. And this behavior is practically something that can model many situations in mathematics. In mathematics, it's very important this, that you understand how to model a situation. Is because normally the mathematics can help you to describe and predict some situations in order to understand the situations better. Like, for example, the pandemic right now we're suffering is described by some models, and they say we're gonna reach like the highest level of contagion or contamination related with the virus we're suffering right now. Okay, but this little set of points right now, if you see, is another way to represent a function, shows you each of these points. And if you remember, these points can be graphed or can be plotted in the coordinate plane. You're totally clear with this. You already have a class related with this. So this is the domain, this is the range. In conclusion, again, every time you are gonna choose the elements in that domain, you can choose them freely if your function let you do it, if your function doesn't have any restriction. For the ones we're gonna study, again, we will not have restrictions. And the range, of course, the range is just a set of values that becomes from that procedure. Okay. So, x comma y. When we talk about x comma y, we're talking about ordered pairs, and the set of all ordered pairs, not like the ones I show you here, which is just a little part, is nothing related with all the points you can get from this function. The set of all ordered pairs will help you to make the graph of a function, and all ordered pairs, of course, will make the function. But that's the situation. There's the situation with this. What happens if they're infinite? Like I'm asking you here, and how you will get a graph of this set of infinite points. Will you graph infinite points? I don't think so. I think we will do something interesting related to answer those, related with this, to answer those questions. This is gonna be more in the second class. Right now, I'm just giving you the tools and the ideas, because in next class, we're gonna make more procedures, not all the theory I'm talking right now. Okay, function. You already have cleared the definition of function, which is for each element of the domain corresponds exactly one element in the range. I will not talk about this again because it's something you already know. But a function rule is an algebraically notation with operation expressed with variables and numbers, algebraic expressions, of course. This function rule is related with what I show you here. For example, a function rule here is 3x, and normally in the exercise this is given, but it's something you can discover too, and we will do it at the end with one topic that is called arithmetic successions, and it's very interesting too. So Normally, the functions represent a set of infinite coordinates x, comma, y that model a curve, or that model may be a line, that model may be, normally are curves, weird curves, but they are interesting too because they help you to understand some um, situations in real life. For example, you can describe the movement of one soccer ball or of one volleyball, throwing it to the air, because at the end it goes and reach a maximum height and then start falling, but start falling at the same way it goes up. This is related with quadratic functions, for example. I will give you some examples later. But in mathematics, it's very important graph a function because you can model and predict many situations of real life. So that's why I will teach you this topic. Is very interesting. I think we will not see like many applications like story problems, but probably you will have an investigation related with this. So when we talk about the function notation is the function rule is the same. For example, here you have the function f of x equals 3x plus 2, but it's the same as you have y equals 3x plus 2. Practically, you can conclude that both are representing the same. F of x is the same as y. That's why I'm saying in second part here that it means f of x is equal to y no matter what way you choose. That function can be represented with any of those. Saying this because maybe you will find more f of x than y equals. That's too common to see it. And both represent the same. What means f of x? Means the function depending the value of x you choose. And what is y? Y is the dependent variable, as I told you in the last slides. So this notation represents the function and will be useful to make a table of x and y values, the value chart, what we call value chart. And with the table or a set of points get it, you will form the graph, okay? And the graph is the best representation of a function because practically with this you describe how is the behavior of this relation you're showing in mathematics. So functions. There are many functions in mathematics, but we will concentrate just in 4 basic functions. You have to remember powers of 2, powers of 3, absolute value, basic operations like addition, subtractions, multiplications, and divisions. So the functions we will study, I'm saying this because if you don't remember as well how to work power of 2 or power of 3, go and review it, because will be useful specifically for these cases. And absolute value is something we talk at the beginning of the first partial. So I think you're clear with the absolute value. So we're going to study a linear function, quadratic function, cubic function, and the absolute value function. So these 4 functions are very interesting and their shapes are different, totally different. Just those are like related, the quadratic and the absolute value. And we will conclude something interesting related with the graph they make, because they make something something like a mirror. And that mirror thing in mathematics has a name, it's called symmetry. We will study the symmetry that they make, and you will understand another new word in math. So each function model a curve or a line. In this case, the linear function is the only one. So we will analyze how to make the curve or line in the coordinate plane. That's for next class. We will study each of these models and conclude how is the shape of these 4 functions. And it's necessary that you remember how to plot points in the Cartesian plane. I mean, what we did in the last class. And each point will help you to understand better, to conclude better the shape that you're making. So it's necessary to remember how to plot points in that coordinate plane. Okay, and with this, we're practically done for today, or with today's class, and I'm hoping you have ideas, clear ideas about the function, the models, because you're doing an investigation, and this investigation is related with these 4 functions. You have to investigate like the function rule. Like right now, here is, for example, this is a function rule for a linear function. But you have to investigate how is the function rule of a quadratic function, of a cubic function, of an absolute value function. So they are very similar at the moment to represent the function rule. All of them will work with an x value, just that this x value probably has an exponent or probably is inside of the bars, for example, the absolute value bars. So please investigate this. This is your work. Don't let these things blank because you don't found information. No, there are many information, and I suggest some in the homework. I think or I left one link, but if I didn't, I think you have many tools to get it. All you have to write is uh, linear function rule, and you will get the answer. Quadratic function rule, and you will get the answer. Cubic function rule is the same as the absolute value. So what happened with the graph? Because I'm asking you for two things. Two things we will do next week, but I want that you have an idea, a previous idea, before we start the with the presentation or the class. Okay, guys, that's all for today. Thank you for your time, and I hope you have clear ideas and start making questions. I think next class, which is gonna be on Monday, I think is gonna be a Zoom session. This Zoom session requires you install Zoom in your cell phone. Zoom is an application to make meetings. And I'm gonna use this meeting, these 30 minutes on Monday, in order to attend your questions and doubts. Okay, guys, thank you for all your time, and I hope you have a good luck with this investigation you're doing. So please send it is for Saturday, not for other days. For this Saturday, send it to the platform, not to my email. Okay, to my email, I will be getting late homeworks. Okay, if you send this in the platform, is better. So thank you for your time. Bye bye.